Free Energy Basics Introduction. Welcome. I'm so glad you've joined me for this class on energy basics. I'm Pat Higby, and I developed the fabulous resources for energy education program here at the University of Northern Iowa. This presentation will briefly describe the content covered and materials needed for the Energy Basics course. To discover more about where this course was developed and the staff who created it, please watch our video introduction. A proverb is a short, pithy statement of a truth or belief. This one from the Chinese philosopher Confucius is my favorite because it summarizes my teaching philosophy. I hear and I forget. I see and I remember. I do and I understand. My classes are more than lectures with illustrations. I want you actively involved so you understand the concepts and the issues presented. Let's start with an example. As noted on our website, you need these materials to do this activity along with us. You could just watch, but actually doing the activity truly does help you understand. So please, pause this video if you need to and assemble these simple materials. You'll need 2 quart-size sealable bags. They can be Ziploc bags, or you can use a wire twisty or a string to close a regular plastic bag. You'll need 2 cups. Styrofoam cups are safer because they do not get too hot to hold. The cup must fit inside the bag. You need a source of very hot, but not boiling water. A coffee or teapot is great, and so is a microwave. You also need a source of warm water. You may just add cold water to your hot water. If you have your materials ready and your water is hot, please follow along with me. For our very first activity for our Energy Basics MOOC, we're going to do an activity called Warm Earth, Hot Earth, and this is going to show energy flows. And it relates directly to the water cycle, which almost everyone has to teach, and so this is really a cool activity. We're going to need to have some hot water, and I'm just using a teapot here, and it should be warm in just a moment there. We're also going to need some styrofoam cups, and we're going to need some Ziploc bags. So I'm going to ask you to pause your video and make sure you've got these materials available before we begin. So go ahead and click pause and then come right back. Okay, you've got your materials ready and we're ready too. We've got our hot water. I'm going to shut it off. We also need to have some faucet hot water. So we've just gotten this from the faucet. It's warm. You can put your finger in it. So we're going to have both of these waters. We're going to have Tracy and Ryan help us. Tracy, I'm going to have you do the hot earth. You're going to fill your cup about 2/3 full with the super hot water. Be very careful. Don't burn yourself. Ryan, you can use the warm earth. And as soon as you've got the water into your cup, we're going to set it into the bag. So we've got our 2 different temperatures of water in there. And if you can take a really close look at your bag and compare it to the ones that we have here, you can see that for the warm earth, well, we might have a little condensation going on. But Tracy, your bag is really doing a great job there. Can you see that? Can you hold that up so that, look at all the condensation we're getting there. Now, why would there be so much more condensation on the hot bag than on the warm earth bag?
Because of the steam?
Yeah, it's because there's enough energy there. In order to change the liquid water into steam or into a vapor, you have to have energy, and there's plenty of energy in your hot cup. Ryan's got a little bit of energy because I see a little bit of condensation, but not as much. So what we're showing here is that when the earth is warmer, there will be more evaporation. That's what we're seeing there, that it's evaporating and it's also beginning to condense onto that cooler cup. Well, what you see there is a wonderful model, and the next generation science standards are really big on models. And so we've got a very nice model of what happens in the real world with the water cycle. So while we're waiting for our cups to process, what we can show is the water cycle. And so shout it out there, Tracy and Ryan, what are the parts of the water cycle?
You need to start with a lake or a water source.
We've got to have some sort of a water source. I could even have it coming from a river here. I'm going to make a little bit of a mountain there. It's always kind of nice to have a mountain. So we have the river coming down from the mountain. Okay, so we have a source of water. And now what else do I need?
You need precipitation, so like rain.
Ah, precipitation, yeah. So I've got some rain. And this is really cool because you can bring in your vocabulary here. So we've got our precipitation. Okay, it's a little bit cold outside right now, too cold to rain. So if it's not rain, what else might I have?
Might have some snow.
Might have some snow, and that's why I put a mountain up here, because that way we can have some snow on the mountain. So a little bit of a snowy mountaintop there. Okay, so I've got my precipitation, I've got my water cycling down into the lake, but how do I get it back up into the sky again?
It evaporates, so evaporation.
Evaporation, and that's what we're seeing in our cups right now. So I'll just go ahead and put in the evaporation. So now we've got our water vapor into the sky. It gets up there, it cools down, and then what does it do?
You have some condensation.
Condensation, just like we have condensation on the bags of your cups. So we get condensation, and usually that's forming a cloud. So we can see the different parts of the water cycle, but what is it that's driving this cycle? It doesn't just happen. There has to be something that drives that cycle. What do we need to have?
And the sun causes the evaporation.
Right, we've got to have an energy source. We've got to have that energy source. And that's why we're doing that water cycle right now for our energy education class. Without the energy, you don't get the evaporation, you don't get the water cycle. So it's very, very critical that you know about the flows of the energy. The energy is flowing, and it's causing that whole water cycle to happen. This is one of those cross-cutting concepts that we hear in next generation science standards. We've got to have the energy, even if you're talking about a hydrological system like this. Okay, we've had enough time now. Let's take another look at your bags there. Can you see how large those beads of water are on the hot earth cup? Mm-hmm. They are huge. Yeah, you've got some there, Ryan, just not quite as many. Now, the next step we're going to do is we're going to take those cups out of the bags and we're going to squeegee the water down. So if this represents rain, we'll just squeeze it out and we'll see how much rain we're getting. So we'll very carefully open the bags, remove the cups without spilling them, and we'll compare the amount of water that you've got in each one. I'm afraid Ryan's coming up a little bit short here.
Yeah, a couple little puddles.
But you've got a nice puddle. Yeah.
Little corners full.
Yes. Let's just hold them up so we can compare the two of them there. It's pretty clear to see that the hot earth cup created a lot more water than the warm earth cup over here. So this is our hot earth. More energy, more evaporation. We have not more rain showers, but when we do have rain, we have a lot larger incidents. So we'll have very, very heavy rains or very heavy snows. And that's the thing that's really kind of strange, is that it's a warmer Earth, but it also means we could have more snow. Because if it's too cold to rain, it'll snow. And it will be in a very, very large, heavy event. So we can expect more flooding as well. Now, on your cups, let's take a look at your cups, because you've got some names on your cups. On your warm earth cups, and I've got some other ones here, I'm going to just kind of read off some of these names. Delpha, Elvin, Burdetta, Albert, Abner. Kind of old-fashioned sounding names, aren't they? That's because I asked the people who did this activity to write down the names of their grandparents. The warm earth represents the earth that your grandparents, your great-grandparents grew up in. It was kind of a vacation kind of earth. But the hot earth, if you look at your names on your hot earth, I've got some Beckys and some Brandons, Susanna. I've got some more modern names because the hot earth represents the earth that our children and grandchildren are inheriting. The earth is, in fact, much warmer. It's going to be a more dangerous world. And why? You've just seen why. Because with more heat, there's more evaporation, more condensation, and therefore heavier rainfalls or heavier snowfalls. Now, we're through with our activity, but we're not quite done with the cleanup. So what we're going to do next is go to the sink. We're going to flip these inside out, and we're going to let them dry. Because I can tell you from past experience that damp bags are a little bit moldy and they get pretty nasty. So as you finish up and you're starting to clean up, be sure you turn your bags inside out and allow them to set and dry. Okay, we've finished our activity. Hopefully you've finished yours. We would like you to take a photo, take out your phone, do either a photo or a video, and post that picture of your results of your activity. Show us your bags, do a picture of the warm earth and the hot earth bag, and hopefully we'll be able to all do a comparison then of how much evaporation you got off from your experiment that you did as well.
I remember the first time I did this activity. I felt like this little boy. Iowa has had several devastating floods in recent years, and this activity helped me understand the science of what was happening. On a warmer earth, there is more energy available for evaporating water, so there is more moisture in the air that condenses into rain. Global warming doesn't lead to more gentle showers. It sets the stage for record-breaking storms. And if it is too cold to rain, we get blizzards. I'll cover more about the energy flows introduced here later. And we'll also explore how much energy is needed to change phases from solid to liquid to gas. Understanding requires more than just doing. We need to process your experiences and show how they are relevant. In Iowa, we use the framework of the 5 E's of the learning cycle. Are you engaged? Did you explore energy and the water cycle? I'll give you a chance to explain, extend, and evaluate in our Warm Earth, Hot Earth assignment. This is the type of presentation, activity, and assignment you will see and do in this course. Many of the activities can be adapted for your classrooms. Now, let's explore how you will interact with me and your fellow participants. This is an introduction to MOOCs, SPOCs, and Course Site. A MOOC is a massive open online course, but technically this course is a SPOC, a small private online course. We're hoping it will grow into a MOOC someday. CourseSite.com was developed by Blackboard, and Blackboard is the learning management system we use here at UNI, so it's a trusted name. You don't need to be registered at UNI to take this MOOC, but if you want graduate credit, you must also register through UNI's continuing education website. I'll give you the instructions later. You can self-register for this MOOC at phigby.coursesites.com. This will bring up my website, and in the My Courses box, you can click on the course that you want to take. Here we're just showing UNI Energy Basics, but we'll be adding more shortly. After you've selected the course you want, for instance, UNI Energy Basics, you have the option to self-enroll. So click there, please. Do you have a CourseSites account? If so, you can click that box. If not, you'll have to set one up. Fill in the requested information, and you're ready to get started. When you begin the course, be sure to read the announcement. If you are one of the first 40 participants, you will receive a free Educator's Materials Kit. That includes a solar car kit, a wind turbine kit, the Best Blade Kit, a multimeter, and thermometers. If you would like to take this class for graduate credit, first of all, you need to be living in Iowa. We can only offer UNI graduate credit for online classes to Iowa teachers. The cost is just $100, a real bargain for graduate credit classes. Now, you may take this course in any of these areas: the elementary, early childhood, middle level, or science education, or technology, also known as industrial technology. Once you're at the website, search for one of the 3 departments we already listed. Choose Online for both the location and instruction mode, and click Search. You may need to scroll down because the section numbers are in the 60s, and then click on the title to see a description of the course. Be sure to make a note of the class number, title, hours credit, and instructor from the course description page. Now go to the enrollment page and fill out the form. Click I agree, and you're all set. Enrolling through UNI Continuing Education does not enroll you in the MOOC. You need to do that at the course site page. Now let's do a quick course overview. Each section will be called a unit. Each unit includes lessons, activities, assignments, evaluations, and so on. Our timeline will be based on the UNI schedule. If you are unable to complete the MOOC by the deadline, simply re-register and start again. It's free. But if you are taking the course for graduate credit, there are no refunds, so please finish on time. Here's our schedule. Our first unit will be introductions. In Unit 2, I'll introduce the book Switch. In Unit 3, we'll work on forms of energy. In Unit 4, we'll work on matter and energy, work and power. Unit 5, we'll start with the warm Earth, cold Earth, talking about those ice ages. In Unit 6, it's warm Earth, hot Earth, trying to understand the energy changes that lead to global climate change. In Unit 7, what should we teach about energy? In Unit 8, energy decision factors. And in Unit 9, how should we teach about energy? In our modern world, we have choices on the way we produce and use energy. These choices lead to consequences that impact our personal finances and the quality of our lives. On a larger scale, we impact the nation's economy and environment. Before we can discuss these in a meaningful way, we need to have a basic understanding of the forms of energy and how energy flows from one form to another. We'll develop a working definition of energy and examine the conservation of energy based on our knowledge of energy forms and flows. We'll see how changes in the amount of energy received by the Earth caused a cycle of ice ages over the past 1,000,000 years. We'll see how recent changes in our atmosphere impacts the amount of energy retained by the Earth to cause our most recent climate change, global warming.
What we teach about energy depends on what we think our students and citizens should know about energy. We'll use information from the U.S. Department of Energy and the Next Generation Science Standards to address this issue. In addition to energy content, this course will also include pedagogy. We'll discuss how to teach about energy by reviewing the latest recommendations for science and engineering practices. I'll do my best to model these practices in our activities and assignments. How can we promote changes in the way we choose to produce and use energy to get the best consequences? Change is hard, but the Heath brothers help us understand how to achieve it in their book, Switch. Your first assignment is to read Chapter 1 and do the quiz on our website. There will be quizzes for the other sections of the book as well, and the opportunity to discuss the book in our book club area. I think you'll enjoy this book. It includes several examples related to education. Other reading materials you'll need for this Energy Basics course will be downloaded from the internet. That means you'll only have one book to buy, and you can often find used copies of Switch on Amazon.com for less than $5. It is also available as an audiobook or digitally for your Nook or Kindle. Energy Basics is a prerequisite for our solar and wind energy courses. If you plan to take these courses as well, please check the introductory video to see the materials needed. These can come from any source, including our free program. Our kit sales help to support our program, so we appreciate your patronage. Let's get to know each other. I have 2 children, 2 grandsons, 1 husband, and a dog. They and my garden keep me pretty busy at home. My husband and I enjoy bicycling. At work, my passion is helping others to teach about energy, because we need all the help we can get to make a safe, healthy world for our grandchildren. I try to walk the walk as well as talk the talk. I'm happy to share with you information about the solar collectors on the roof of my garage and my new Chevy Volt. Now it's your turn to introduce yourself. Please share some information by writing a short paragraph about what and who you teach. A photo or short video would also be nice. See the website for instructions. This concludes our first lesson. You need to get Switch, read Chapter 1, and take the quiz. You need to tell us about yourself and take our pre-course survey. Do these assignments and join me again for our next section of Energy Basics.